So the time is 11:11 p.m. on Sunday. Just got back home, settled some admin stuff, and right now I'm about to go into a leak code question. So, based off this question, we can see this question as a maximum subarray. So earlier on during my mock interview attempt with Mr. ChatGPT, I actually came up with a question that is given an array of integers and an integer k, return the length of the longest subarray whose sum equals to k. So this question is a little bit tricky. Basically, you are supposed to keep a running length, running sum of all the elements, and then you check if it exists in a map, and if it does, so basically prefix sum minus prefix sum minus k is equals to k. So it's in a way like a complementary approach, and you just check whether the length is larger. So this approach is on runtime, on space. So I'm thinking for this maximum subarray question, I can use the running sum approach again, but hold on. Okay, where was I? Okay, so I believe that we can create a let running sum equals to 0, and I don't think we need a map because by taking a look at the question, so given an array of integers nums, find the subarray with the largest sum and return the sum. So we have to go through one by one. And a subarray is a contiguous non-empty sequence of elements within an array. So based off this, you know that there is no sorting required, because if you sort, you destroy the non-empty sequence. And yeah, we already know that if uh if the nums dot length is equals to 1, we will just return nums 0. Yeah. So this is the edge case. Oops. Next. It is a array and divide and conquer and DP. So this question falls under one-dimensional DP, if I'm not wrong. So recommended time and space complexity is a solution with on time, O1 space. Okay, so there is no need for a hash map, unlike the previous one, where we actually instantiated a hash map because we needed to track the indexes of the longest subarray and to compare it. So in this case, we just want the largest number. All right. So let me just iterate through. Or we definitely need a loop. I less than nums dot length plus I. All right. So we'll look through. So first of all, okay. Now we do a running sum. So running sum plus equals to nums 0. All right. So we definitely have to run this. So now at the first part, I will get 2. Okay. Then let's check. Let largest sum equals to 0 as well. Okay. This is before traversing array. Then I will need to instantiate something to track the index of the subarray. Maybe we can check the smallest sum so far. This is 0 as well. So see, if running sum is greater than largest sum, I will set largest sum goes to running sum. Right. So in the event I'll start with 0, in the first iteration I'll get 2. Right. So in the next iteration I will get -1. So that falls in the else section. Okay. Else, the smallest sum, I want to see if it's not bigger, right? I want to check if it's smaller than the smallest sum. So why I'm doing this is I'm capitalizing on the prefix map, right? So we find the largest sum along the way. Okay, find the largest sum along the way. And then in the event that we find the smallest sum, we will want to subtract it from the subarray. So let's see how it goes, all right? So at this point, -3, so I get -1. So else if running sum less than smallest sum, I'm just throwing ideas out there. I will do smallest sum is equals to running sum, right? Do, 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 do. Okay, so now we have -1 over here. Next one, the running sum will be will be 3. Okay, so 3 and -1. Do I add it? I don't want to add it because it will make my number smaller, right? So if 3 is if let's say the smallest sum is negative, so the running sum is bigger than the largest sum. But how do I know when to reset it? I reset it when the running sum is less than 0, right? So maybe instead of saving the smallest sum, right, I will do running sum. Running sum is equals to 0. So at this point, 2. And then I get -3 is equals to -1. And when I reach 4, I don't want to compile it. I will check if running sum at this point, is it greater than largest sum? Okay. If running sum less than 0. Yeah. So in this event, if it's negative, it will actually reduce your sum largest number. So reset to 0. If it's 0, we want to keep, right? We want to keep if it's 0 because next one is potentially part of subarray. Yeah. So let me just not use smallest sum before, and then we'll just console.log running sum, the largest sum. Okay, so return largest sum. We run. So in this case, my output is 16, right? So let's just check. Console.log I and uh running sum. Okay, let's run. So I get 0 at index end of just do end of I. So end of the 0 pass, my running sum is 2. End of the first pass. Oh wait, sorry. End of the 0th pass, my sum is 2. End of the first pass, my sum is 0 because it's -1. End of the second pass, I get 4. End of the third pass, I get -2. Right. It's still not 0, so it means that. So reset to 0. And then the third pass, and then the fourth pass, end of the fourth pass, right, which is 2, I'll get back 4. End of the fifth pass, I'll get back 1. Sixth pass doesn't bring me down, but 7 pass makes it bigger. All right. So, okay, I believe that there will be some errors. So -2 and -1. So end of 0, I get 0. End of first pass, I get 0 because it all enters this. All right. So in the event that they are all negative, right, I will have to, does it bring me down? Right. So I will have to consider, all right? So I cannot just lump sum. So this one, but issue arises when all are negative. So instead of initializing the largest sum to 0, I will set the largest sum to negative of the largest. So -1001. Right. So I will use this test case and I'll run it. Mm. Okay, there's nothing wrong with this code segment. So I will check. If running, if nums I itself is bigger than running sum, then so negative is bigger, I will choose -2. Right. Else if running sum is less than 0, we want to okay. So running sum. I need to account for negative numbers. Okay. Check. Check. If uh nums I is itself is greater than running sum. I mean, I'm just trying to fix the bugs right now because based on this, it's wrong. So if nums I itself is greater than running sum, why not you just set running sum is equals to nums I, correct? So if nums I is less than 0 and nums I is greater than running sum, we can just set num running sum is equals to nums I, else running sum with 0. And then we move on. Move on. Hmm. So our console.log mm, running sum. Okay, let's take a look. -3. Nums I. So nums I at I equals to 1. Nums I is greater than running sum, right? Nums I is less than 0. Does this actually run? Hmm, largest sum. I need to. Okay, so this one is just specifically for negative numbers, right? So if my number is negative, but it is bigger than the sum so far, I will just let it be the largest sum. Or I can just set largest sum, right, to make it more consistent. Hmm. Oh, wait, I can do running sum. Maybe running sum is the correct one. Okay, so nums I. Okay, so now I maybe can't do this, right? So I need to check. So I will check running sum plus equals to nums I. So running sum plus equals to nums I. Then I will do if nums I is greater than the running sum, I will just uh, let it set, right? So actually this is a guard clause because it applies to the previous scenario as well, right? If nums I itself is greater than running sum, we should just continue off it. So we just do if greater than running sum, then we'll do running sum is equal to 0. And then largest nums I is greater than largest sum. Largest sum is equals to nums I. Correct? Hmm. Running sum should never be. Okay, really gotta be running through step by step again. So -1 and -2. Wow, that actually worked. Just continue off it. Perfect. So I think this one I can remove. So the idea is pretty simple. So we will keep a running sum, and the largest sum will be negative of this. So this accounts for negative numbers. Okay. So if let's say the first number is negative, right, we will still consider it the largest number so far. All right. So largest sum keeps track of the largest sum of the subarray. So for let I equals 0, I less than you, basically just traverse the array. The running sum is equivalent to 0 plus equals or initialize to the first element. Okay, so if the number itself is greater than largest sum, we should just continue off it. We should do this, then continue. No, we actually can't continue. Oops. Hold up. Let me hit the can. All right. I just went to the toilet, came back, and I thought of something. So the running sum is the sum of the first element in this case. So what I will do, right, is I will also dot log I running sum and largest sum. So I nums I I'll run. Right. So in all these cases, the running sum will plus equals to nums I, right? Which makes this part minus 1. So if nums I is greater than the largest sum itself, which minus 1 is not bigger than, minus 1 is bigger than all this, right? I will set it to minus 1. But I can't do this. I still have to do a comparison of running sum versus largest sum, right? Because this one just ensures that negative numbers are padded to largest sum. They have a chance to go up there, right? So the actual comparison comes later. So if running sum itself is bigger than largest sum, right? It means that while this element is bigger than largest sum, right? The 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 numbers before that have made this even bigger, right? Which is why in this case it kind of failed. So if you look at this, all right. So I think okay, let's do a continue and run. We'll see that this is wrong, right? Because first up, I will do minus 1, and then I will set, and I'll set it as minus 1, correct? So nums I is bigger than largest sum. So when you reach index 1, minus 2 is not larger than minus 1, right? So the largest sum at this point is minus 1. Minus 2 is smaller than that. So we will skip this guard clause, right? So running sum minus 2 is not bigger than a minus 1 itself, the running sum. Right, so hold up, let me get my brain together. Minus 3 is not larger, so we will just continue and then we'll do this. So hold on. Let me just console.log largest sum minus 1. Hold on. Then why does it ever get a minus 2? Because I will do running sum. Ah, correct. So running sum is minus 3, correct? Because it's minus 1 plus equals minus 2. And then it will enter this one because minus is less than 0. So if it's negative, it will reduce your largest number to 0. Right. So it will check if the nums itself is greater than running sum, which is minus 2. And then it will just set it. Right. So without this continue, what will happen? We will set running sum. Right. So running sum is actually equals to nums I. And then we can continue. All right, never mind. You know what? Let me just work without it. So without the continue, right, we will do some setting over here where if the nums I itself minus 2, minus 1 is less than 0, and this minus 1 is greater, we will still set running sum to 0. Correct. So this case, right? So at index 0, where it's minus 2, eh, hold on. Let me just get the numbers right. Hold up. Isn't nums different? The input is minus 1, minus 2, right? And then if I do this, the input is minus 2, minus 1. Oh, so it's minus 1, minus 2 as well. All right, so minus 1, minus 2. Let's just trace how it happens, okay? Index 0, nums is equals to minus 1. So the running sum is 0 at this point, right? Because we reached this part, we didn't continue, we carry on, and then we set largest sum is equals to nums I, which of itself is minus 1, correct? And then we will do running sum equals 0, and then we'll move on, okay? Come to index 1, the running sum is equals to 0 minus 2, so it's minus 2. So your running sum is minus 2. Okay, nums I is not bigger than largest sum, right? So largest sum is still equals to minus 1 from before. So running sum itself is minus 2. It is not bigger than largest sum, but running sum itself is minus 0, right? So right now, it will come in here and say nums I less than 0, nums I greater than running sum, which is false because running sum is minus 2. So we'll set running sum to 0 as we console log here, and then the largest sum is minus 1. So why is it that when I add a continue here, the code breaks? Right, so let's take a look. Running sum is now minus 1. Okay. If nums I, which is minus 1, is greater, I will set the largest sum here. Okay, which itself is minus 1. Right. So I'll do a L minus 1. Okay. Then I continue. Round 2. Running sum is equals to minus 1 plus equals minus 2. So nums I minus 2 is not greater than largest sum. So it never enters this block. So minus 3, the running sum is now minus 3 is not greater than largest sum, which is minus 2. So if running sum is less than 0, which previously was 0, so it never entered this loop, right? So let's just say console.log running sum, okay, to R. We'll see that it enters it once at minus 3. So if nums I is less than 0 and nums I is greater than the running sum, then the largest sum will be equals to minus 2. So the first continue is wrong, which I'm not sure if it can be remedied by saying running sum is equal to 0. So the first case will be wrong. So even with the guard clause, we can see that setting the 0 to running sum is too early is not good. So be it by luck or by skill, I managed to answer this question. The time complexity is ON and the space complexity is O1 because there's no extra space, just comparison, and time is just one single pass. So with that, I'm officially more than halfway through blind 75. 38 times 276. Yes. So good night.